introduce our first speaker, Andrei, and I guess I'll let him introduce himself. That should work pretty good.
Yeah.
Great.
Can you guys hear me?
You might want to speak to this
Might
one.
wanna- okay.
Let me just get you up here. Oops. Where is it? It is this one, right? That's what you want to start with?
Yeah.
Okay, perfect. Yeah!
Thank you for the introduction, Ben. I really like this event. I think I've attended one like 6 months ago or something. It was really, really interesting. I wish I came more often, but I really appreciate the opportunity. So my name is Andrei. I want to talk to you about this open source project that I've started 2-3 months ago, and get feedback. Get people interested maybe to use it. It's a smart document router. It's a tool for AI document processing that connects to your system of record. And a little bit about me. So I'm more of a back-end engineer, if you will. I kind of started doing front-end last year, so I kind of learned along as I did this stuff. So for me to kind of speak about it is a way for me to learn it. So that's pretty good. Yeah, so just a quick introduction. What does the document router do? So I have about 40 slides, so I gotta see how quick we can go through this. I want to talk a bit about the technology behind, but also show you what this does. Please feel free to interrupt me, because if we jump from topic to topic, if you wait to the end, you might not have a chance to ask your question. And also that would slow me down a bit, which would be good. All right, so this is how the UI looks like, just to give you the lay of the land. Basically, you have a way to upload PDF documents, to tag them, to basically categorize them with tags, and then to run extraction based on prompts. So the way to think about it is pretty much what you can do in ChatGPT or in Claude when you upload a PDF file and you put in the prompt questions. You can even define a schema for extraction. You can do the same thing with a DocRouter at scale. And you can systematically configure these prompts. And this is an example of how the prompts are, the schema for the extraction is configured. You even see a JSON schema in here. So you define these extraction schemas, and then separately you define the prompt, and you select the schema that you attached it, and you pick the tags. So what's this thing with the tags? Well, if you process hundreds of documents, you don't want to run all the prompts on all the documents. You want to basically have a way to select which prompts you run on which documents. So for example, say that you extract from a company annual report. There's all sorts of tables that it has. So maybe you have some prompts for some tables, but at the same time, you want to process different documents that have nothing to do with annual report. So by using tags, you can select which prompts run on which documents. You can also select the model in here. And the process is basically upload file, get the extraction. So what's happening in the background is it's going to run OCR, and it's going to run the LLM with the prompt and the schema. And then you're able to edit you're able to see the extractions and actually edit. So let's see here in practice, how does this look like? Yeah, so this would be where you upload. You can come in here and select. In this case, I've configured 2 tags. One is for CVs, for curriculum vitae, for example, or annual reports. You would come in here and upload the document. You would configure these schemas and prompts. So for example, let's say consolidated profit and loss schema. So these schemas are versioned, by the way, so you maintain a history of all the configurations. And you can add fields or remove fields. You can see the JSON schema here. So one trick here is the JSON schemas that you can configure are actually a bit more complicated. They're not just like flat key value sets. You can have lists and embedded things. So I have to do a bit more work to support that in the UI, come up with a slick UI to design that. For now, that still needs to be implemented. But anyhow, so you define the schema, and then when you go to define the prompt, let's see the same prompt here. For example, you can really go in Claude and upload the PDF and try a few prompts, see what works, try a few extraction schemas, and if you're happy with it, you kind of save it in here. and you can select the model. And how is this implemented underneath the scene? I'm going to talk about this. It's using light LLM as a way to a portability layer for the language model. And the prompt can be very complicated. It can be multiple pages. So for example, in my consulting work, we do extraction for revenue cycle management, billing information, insurance records, labs. The prompt can be literally, I don't know, maybe 20 line items. And there's a whole discussion here about, okay, how large the document, how large can the document be for this? How to handle situations where maybe the document is too large. Now, fortunately, some of these language models, and maybe we get a bit of time at the end to discuss the differences between these ones, but Gemini Flash is actually great because it's a fraction of the cost now, and it really has a large context window. So it's one of the good things that happened recently. Okay, so then eventually you upload these documents, you get the extractions, then you can actually search on the page. So this is the trick here with these language models. They're not going to give you a bounding box for the extraction, but because there's OCR happening in the background, you get bounding box from OCR, and you can integrate it this way. Behind the scenes, this is TextRact AWS OCR. And you can also edit these extractions. So you can have a human in the loop. And this is very important because so we're not doing RAG here. We're doing precise extraction. So, and it's financial data. So you need to have a way for the human to kind of correct the things that the AI does wrong. And there's a bit more work that can be done here, but you can see kind of the contours of how this can be improved, how you can build data sets with it, how you can have evaluation and so on. That's not implemented yet, but that's kind of the direction. And also there's workspaces here where you can have multiple people collaborate on one workspace. So I don't know if people are familiar with Databricks, but it's kind of an idea I stole from thinking about how Databricks does it, and I try to kind of replicate the same design. Okay, so that's the presentation of the how it looks. Now the more interesting thing is like how was this implemented and what technologies are behind the scenes. Okay, so okay, actually one more thing I should show is everything that you do point and click in the UI you can do programmatically, and there's all these REST APIs where you define a token and when you upload or when you define a prompt or a schema, you can do it through API. So this can be integrated programmatically. And if you have a system of record or an ERP, you can basically put it inline between the sources of data. Let's say you process a fax queue, for example. And you can, using tags, or maybe in the future using workflows, you can select the documents you want to process that you can process with AI, but keep the ones that you don't want to process separate because you won't be able to fix all the workflows in one pass. So that's a big issue with the, when you integrate the product, you're not going to be able to solve all the problems in one day. You have to pick the flows that you solve first. So those that you can sort out, you can ingest the structured information in the system of record and thereby save time. Okay. Enough about that. What's the technology behind it? And this is all stuff that I've learned in the past 3-4 months. So I was very scared to do React programming for a long time. But Big Unlock, the cursor text editor now makes it a lot easier. So I kind of took a plunge, and it turned out it wasn't that difficult, actually. So there's a Next.js, and we're going to talk about the difference between what is Next.js versus React. There's a Next.js implementation for the website with a client and a server, and there's a backend with Fast API. We're going to talk about that at some point. Then there's all these workers that need to do work at scale. So one of the issues here is that when you process hundreds of documents, the OCR or the language model prompt will take some time to run. So you cannot do this sequentially. You have to parallelize. There's all this orchestration you have to implement and kind of scale the workers to handle the load. Light LLM is the portability layer over the language models. And the backend is just a simple MongoDB, and we're going to talk about why this was chosen and how that works. So the tech stack would be React, Tailwind CSS, and all these other things that we're going to go through. But I want to go kind of one by one through these things. So here's the deal. If you have an AI text editor that does many things for you, you can start taking a step back and not be very worried with the deep technical details and just have the vision of how to fit the pieces together. And as the project becomes bigger, you also want to structure the code in a way that the text editor can actually work with it. Because if you do random things, then the text editor, as smart as it is not going to be able to deal with it. But React is really good for Cursor. Also about the text editor, so there's two main text editors, Cursor and Windsurf. Cursor, I want to say it's a bit more advanced, but Windsurf is going to basically achieve feature parity pretty soon. I think both will be just as good soon enough. But I actually tend to use Cursor more because I like to be more in control of the steps that I do. And Windsurf, I have this impression that it kind of jumps and does things a bit too proactively for me. All right. So what does React do? Well, React is for single-page web applications. So in this case, I want to be able to navigate through the page and do edits without changing the URL. And I want to have a component-based architecture. So for example, on the extraction page, you have the layout of the page, which is a component. And you have these embedded components, which would be the left sidebar and the viewer for the PDF. And these components can be reused on multiple pages. For example, on the dashboard, you'll be able to reuse some of the components on other pages. And these components in React, they maintain their own state. Like, what is the state here? Well, in this case, it would be the extractions. That would be the state. So that would be the useState function in React. Also, as the page is updated somewhere, like, for example, let's say that I change the workspace from, what do I have here, prod, to another workspace. I need to be able to update the rest of the page. So that's going to be using contexts. And just kind of at a very high level, how does this work? Well, there's this document object model, the DOM, that basically has the XML structure of the elements on the page. And React is going to basically populate this DOM from the backend, from the server. Remember, there's a server side here and a client. Actually, no, probably React doesn't deal with client and server. So basically, React is going to update this DOM dynamically depending on the operations that you're performing. And for an example component, let's say the layout, this is the code, the JavaScript code that you would have for this. And the components would be layout, header, sidebar. Sidebar is right here. You can see it. Main content is going to be actually its own page that is within the layout, and then the viewer and the sidebar. And the children, so children are parameters to this layout component, and they're called props in React. But you can think of them as parameters, really. It's just a funky name for parameters. OK, so what is JSX? Well, on the page, when you write your React, you're going to have classic HTML tags like div, for example, and these are going to be lowercase. And the React tags are going to be capitalized, like PDF viewer. So that's called a JSX tag. So that just makes it easier for the AI to kind of configure your React. So it's an example JSX here. And the idea here is that you have this compiler of the page that you basically pass this XML with HTML and JSX, and it transforms it into JavaScript and HTML. So you can see the result of the compilation, which I don't think is one-to-one to what is up here in this example, but that's kind of the logic here. So there's an extra compilation step with React to actually build a page, including the JavaScript. All right. Tailwind. OK, what did we come with Tailwind? Well, in this example here, for example, these tags here for the class name, these are going to be, these attributes here are going to be Tailwind utility classes. what is Tailwind? Well, so that was, again, something that really scared me. It's like, I now had to learn Tailwind. CSS was very difficult to kind of wrap my head around it, but Tailwind is actually a simpler way to do CSS. And basically, you can think of it as a utility-first CSS. So basically, anything that you can do in cascading style sheets, CSS is cascading style sheets. For example, the type of display, flex, can become a class name attribute. And these classes, they're called class name, not class, because class is a reserved token in JavaScript. So it's basically a more efficient way to write CSS, but you can still use traditional CSS. So for example, one advantage of Tailwind, well, one is that the AI text editor really knows Tailwind really well. So I don't have to be a graphic designer to design my page. I just work with cursor to kind of design the page, and I'll show you an example a bit later. The other thing is like the design is responsive. Like I can load it on the phone, and even if it's a smaller form factor, it's going to be rendered properly just because Tailwind is designed to be responsive. So to give you an example, let's say I went to a Sloan School event, and I just met a potential customer. I was showing him this. And as I was talking, he basically pulled it on his phone, and I hadn't even thought that was possible, but it kind of just worked because it was Tailwind, and he was able to really try it hands-on. So that was pretty cool. Now, Tailwind, the features of Tailwind that are used in DocRouter, so I did a query in the text editor. Kind of 80% of the features come down to flex layouts, or spacing, like for example, M3 would be margin of 3 pixels, P3 would be padding of 3 pixels, MX would be margin, horizontal margin, and PY would be vertical margin. So basically, you don't need a lot to kind of learn Tailwind. I would suggest spending a bit of time to understanding flex. There's also grid, but I don't need grid. Grid is too complicated. And just basically found a YouTube about flex, really bridged me over. So that was pretty good. And one other feature is this ability to use, let's say, open question marks. So basically here you dispatch on a variable in JavaScript, and you pick the right width in here. So that's pretty much it. I was basically scared for nothing. Tailwind is not that hard once you start to play with it. And in terms of how to design things, I have 3 slides to kind of show you a bit how I'm doing this. So one of the problems is in the schema definition, I have a way to define field names, right? But it'd be nice to have a description of these field names. And the initial UI doesn't have a way to specify this description, because I've not implemented yet editing directly the JSON schema. I only implemented kind of point and click on this side of the. I realize the font is actually very small here. Maybe if I make it a bit larger like this. Yeah, so you can see you can set the names of the extraction fields. You can set the type. They're all strings. But I don't have a way to edit it. So I prompted cursor, and I basically asked it, hey, give me 3 options to solve this problem, right? And that's a trick that I've done multiple times. Just ask it to give me options, and also ask it to an opinionated option. It's like which one is the best option. And the first option that it came with is inline description field. So it basically created this input box where I can enter the description. But it kind of messed up because the other buttons disappeared here. So this would be good, but I would have to do a bit more prompting to clean it up. I think it can be made to work. The second one was an expandable field row, where basically you have this arrow button that when you press, then it expands, and then you can edit. But again, the first draft from the first prompt, it put the component there, but if I click on it, it didn't work. So it would require a bit more prompts to sort it out. And really, it would work. I mean, if I was to continue down this path, it would really solve all these problems. And the third one was to put an eye for information, and this one would pop a modal, and this actually just worked. However, Cursor recommended option 2, so basically if I was to kind of really implement this, I would go back to option 2 and do a few more prompts to sort out how to implement this. So that's kind of how I do a lot of the design for graphic elements. Seems to be working fine. Let's talk about Next.js here also. So remember, the architecture diagram has this Next.js client which runs in the browser, but there's also a server piece that runs on the server. And then there's the rest of the thing with fast API and so on, right? So why would you use Next.js over plain React? So first of all, React is more or less, most people use React. Next.js is a choice. There's other alternatives, right? I picked Next.js because it seemed like it was developed enough that I was sure that Cursor would know it really well. So there's probably other alternatives that people could pick. So it does server-side rendering and static-side generation. So what does this mean? Well, basically, the server side is going to create the basic DOM with some JavaScript code and send it to the client in the browser, and the browser would populate the elements that are not fully populated by the server. So that's one thing that it does. The second one is it does this file-based routing. So what does that mean? Routing is basically the URL, the path in the URL. It's not kind of network routing. It's a bit confusing, right? Basically, the way you structure your files in the source code, that's how Next.js is going to display the URL paths. And the third thing is these API routes, meaning that you can implement REST APIs inside Next.js. So for the project structure, because that's a bit more interesting, in the front-end folder, you have basically the structure of the application. You've got source. Everything's going to be under source. And then pages are going to be under app. And then you see the path. So for example, if I want a page that says app, that says orgs, and then the organization ID, and then let's say PDF viewer, and then the PDF ID, the dynamic things in the URL will have to be within brackets. So that's a convention in Next.js. Which sounds a bit artificial, if you will, but it's easy to kind of see where the code is and understand it really quick. And then you have a folder for components and for context, and we talked about context really quick. Now, since I'm talking about the project structure, there's also a backend, which is the Python code. And the Python code will have the fast API implementation, and we're going to talk about this a bit in more detail. So now, why choose fast API and not just implement it all in JavaScript? Well, again, it's an implementation choice. It's a data science project. So Python is better, in my opinion, for data science. I'm more likely to do things quickly in Python. So I pay a price, right? Because now I have basically two backends in here. So I got to be careful to put most of the backend functionality in Python and not in the Next.js server. But on the other hand, now everything can be driven through APIs really easily through fast API. So if I'm disciplined and I don't mix things up, then I'm better off. And actually, that's one of the risks with these AI text editors, that you can do things multiple ways. And if you're not careful, the AI editor will tell you, oh, I know you started this way, but from now on, this feature, I'm going to mix things up and put the API somewhere else. So that's something that you got to be really disciplined and kind of not let the editor take ownership of the project and kind of impose the structure that you want in the project. Otherwise, it's very hard to manage the project. And then there's these workers that we're talking about. There's a folder for that. And there's a portability layer in here, a Python module for portability. If you found like a data lake portability layer that has all the database functions and all the LLM abstractions and everything. All right, server versus client component example. So now we're back to Next.js. So this slide talks about the hydration process. It's talking about what I've described where the server prepares the DOM and has some JavaScript code placeholder, and that gets shipped to the browser, to the client, and in the browser, those get hydrated, get populated. So what's dynamic on the page is actually on the client side. So an example here is, for example, on the upload page, the base component is going to be on the server, the upload page is going to be on the server, but the actual document upload that you point and click and dynamically changes, that's going to be a client component that is hydrated from the client. When to use server versus client components. So this is a slide that basically says, hey, if you want to access your backend database or access data, you got to do it from the server, right? Because the server has the authentication tokens. You're not going to put those in the browser. Sensitive information, large dependencies, that's server side. But whatever is interactive that you have to click or you have to change, page up, page down type things, something that uses state or life cycle, or really if you want to use the browser APIs in some cases, or maybe even the React APIs, or some custom hooks that depend on state. So that's going to be on the client side. So I got to be honest, I struggled a bit with this server and client division. So I'm still trying to understand how this works, but it just works. So in the end, I think I'm happy with this, and I also don't need to fully understand everything to kind of get something going, right? Next auth. Okay, so a big problem here is you need to authenticate. You need users that can register, can log in. You need to be able to log in maybe with a Google account. So this is a module that sits on top of Next.js and provides features for authentication. And I've struggled with this quite a bit because it's got multiple versions. They change the version all the time. Like one problem here is that I have to tell in the system prompt cursor exactly which version of NextAuth I'm using because it keeps giving me the wrong suggestions. So finally, I think I got it to work. And the main component would be this auth.ts file where you define your, let's say, your GitHub OAuth credentials and your Google OAuth credentials, which you go in GitHub and Google to create so that people can sign in directly with a Google account. And then you have to implement these callbacks for sign in, for session, and so on. So, okay, I think that's what I wanted to talk about Next.js and NextAuth. That's just the flow of events when you log in, and the key here is that it's not going through Fast API, it's actually going through Next.js server for logins, and from there it's going to MongoDB. Fast API. Okay, so now it's a bit more in my domain because I'm more of a Python person. So once I reach Fast API, I'm a bit more home free. So the idea is I want everything to be programmable through REST APIs. Some people don't necessarily put Fast API here. They put, for example, Flask, or they put Django, which also have a bit of a front-end functionality. But Fast API is just if you want REST API implementation. So basically, any function that is available in the UI is available in the Fast API. And Fast API even gives you this nice web page listing of all the APIs that you implement. Okay, so how do you implement a Fast API, like a basic Fast API? Well, you have to pip install the Fast API module, and just create an app with the Fast API class, and then you define these with these decorators, you define the paths for the REST APIs. In this case, it's just a simple version API. And then you define how this function is going to provide the REST API response. And this has to be async. So we're going to talk a bit about async here. I think that's an interesting Python thing that Also, I got to learn a lot better now that I did this project. I also talking to my coworkers, I had a sense that people don't always understand how async works in Python. So that's an interesting thing to discuss. And then in the main function, you have to start the server. UVI core is basically a web server implementation that is adapted to Fast API. And when you start it from the command line, like in your Docker file, it's going to be this UVI core command. All right, so let's talk about the async and the app decorator. So async and await. So this is a way to make functions asynchronous. So there's an example here of a synchronous function, this getUserData, which will just fetch from the database, but that's going to be a blocking call. So if this takes 200 milliseconds to return, then your application is going to wait 200 milliseconds, right? And Python has a global lock, the so-called GIL. So nothing else will run until this returns. So the trick with async is to basically say, hey, await this call, but while you're waiting, just return control back, and let me do other potential network operations. So in this case, let's say with a language model, if I want to do 100 language model prompts, and if I do await, I basically send a request, 100 requests out, and I don't have to wait for the first one to come back. They happen in parallel, and they come in one by one, and they're processed in parallel. And what's happening really behind the scenes is that there's this background event loop. So now event loops I know because from my C programming times, I always used to program with an event loop and a state machine and message passing. So I'm not scared of event loops. But in this case, the event loop is hidden. I don't have access to the event loop. It's just done for you. All you see is this async and await. That's all you basically need to know. And you always have to await a coroutine. A coroutine is basically getUserData is a coroutine. A coroutine is a function that is an async function. That's what it is. So I was a bit interested to see, okay, what's happening behind the scenes with this await. And it turns out it's just syntactic sugar for yield. So yield is another Python primitive that is used to basically, let's say, if a function returns yield, then it's going to remember its state and the local variables, and next time it's called, it's going to continue from that point on. So that's not something that you see in C or C++. It's just a specific Python thing. But it's used, for example, for iterator implementations. And the point is that this await is basically using yield under the scene. And if you dig really deep down to see, okay, where does the actual ultimate non-blocking system call happen, well, it's going to be at the bottom, it's going to be a select or a poll or an epoll. So people who do C programming and C++ might be familiar with this if they do network programming, because that's also kind of how you structure your event loop underneath. So select would be, hey, I'm going to give you these sockets, list of sockets, and I'm going to select for read events or for write events, and I'm going to wake up when one of them is ready to read or ready to write. And that's a way to do asynchronous programming. So that's basically what's happening down the stack in here. But for all you care, it's just an async and await. OK, so one problem is this event loop, how to start it, right? Because you have to start the event loop somehow. If you're in Fast API, there's this UVI core run that is going to start the event loop. So you don't have to worry about it. It's started for you, really. Whereas, let's say in the workers that I'm implementing, you have to start this event loop by hand, and it's going to be this async IO run. And then if I want to kind of spawn out and listen for multiple coroutines, there's this way to do a gather so that I can start multiple workers and have them kind of work in parallel. So, so that's it. That's the kind of the complicated thing. The rest is just plain async and await. I don't know. Am I going too fast? Is this good? Any questions about any of this? No. Feel free to interrupt me. If this is like too much too fast or. Yeah. So I was talking about workers. The idea here is again to parallelize access to the OCR service. In this case, it's an AWS service. It's called Extract. and also to parallelize access to the language model so that you don't wait too long for these. Okay, the decorator, the app decorator. This is basically what tells FastAPI that this is going to be a URL that implements a REST function. And this is basically how it kind of unwinds it. It's going to add this route when it sees the decorator. That's basically how it's going to do it. One thing about these decorators is that you have to specify the syntax of the arguments to the REST API. So this is where PyData comes into the picture. So PyData is another Python module that allows you to define the structure of objects, if you will. Very, very simple definition of, for example, in this case, to post a document, to upload a document, I want to know how this document upload structure is specified, and this is how the curl looks like. You see these documents, you have to give a name, you have to say what the contents of the document is, it's going to be a tagged document, so a list of tags. And this would be the PyData schemas that say, oh, for document upload, you just have a list of documents, and then each document has the name, a content, and a list of tags. And by importing this and putting it as an argument in here as a type, FastAPI is smart enough to kind of enforce that schema. So that's pretty cool. Like FastAPI really does a lot of work behind the scenes for us. And PyData schemas also come into play when you deal with structured output for LLMs. Okay, so why do we need structured output from LLMs? Well, with LLMs, you have the option to basically ask it nicely to say, hey, can you please give me JSON, and can you please tell me, give it this structure in the JSON, use these keys, and so on. If you ask it really nice, usually it's going to do it. Maybe it's not going to really give you the JSON. Maybe it's going to give you a markdown of the JSON, which then you have to parse. But more recently, most language models have a way to specify in the arguments that you pass into the language model the extraction schema that you want. And then the model actually is trained, in that case, to give you exactly that extraction schema. And furthermore, it can give you the description of the fields that you want to extract, which is really helpful. So all these companies like OpenAI and Anthropic and so on, they basically build these pipelines in there. So whenever they build a new language model, they're going to pass it the pipeline and get the structured output for it. So it's already some machinery that you can kind of rely on. That next version that they have for the language model is going to support it. And if you want to extract tables and things from the language model, you might as well take advantage. And the way this is used in the code, well, JSON schema at the level of the language model API, but also they have the option of using PyData schemas, because JSON schema and PyData can be kind of used interchangeably. And this is an example of the PyData schema inside the smart document router that captures the schema, if you will, so how to express a JSON schema in a PyData schema. It's kind of a meta specification, if you will. Okay, what else? And now these things are going to be a bit easier going down. So AWS and Mongo. So AWS, just using some services for OCR. For registering an account, you need a confirmation email. So there's SES. Lightsail for hosting. There's multiple options to host a service like this. But importantly, you want to configure with software as code. So this is where Terraform comes in. We're not going to speak about Terraform. My experience with AWS is that I can do everything in AWS, which is great. But the problem is there's multiple ways to do it. So you can always get tripped by kind of starting the wrong way. And also, it's very hard to get permissions right in AWS, actually, all of these clouds. So spent a lot of time with this sort of stuff. But if you use a tool like Terraform, then that really simplifies things, because when you make mistakes, you can kind of correct it in the code. You don't have to point and click to correct it. And the choice of MongoDB, well, so my thinking is to always use the simplest tool that solves the job. And in some sense, the document router is, if you want, the simplest tool that sits on top of LiteLLM that is able to process at scale documents. So yeah, MongoDB is just basically a collection of JSON objects. And it scales horizontally very well. So it's an eventually consistent database, meaning that when you save something in the database, multiple nodes need to kind of get the information, and eventually they're going to become consistent with each other. But the fact that you saved it, sometimes one of the problems is that when you read it right away, if you read it too quick, it hasn't really become consistent yet. So that's something to really pay attention to. So let me skip some of these details here. Yes?
I guess my question is regarding the choice of using like a non-relational database. Considering that you're trying to integrate with like ERP systems, which are relational databases and are transactionally consistent, how do you reconcile with that?
That's a really good question. So let me repeat the question. Why use an eventually consistent database, not a transactional database, especially since we deal with systems of records, and typically those are implemented with SQL, right? So I've struggled with this. But ultimately, I view this DocRouter as kind of a transition step in the pipeline. So, but I agree that if this has to be a system of record for something, then you probably want a Postgres or something in addition to Mongo. One other thing that I like with Mongo is that you can really implement a lot of the AWS functions, like for example, queues and pub subs. You can kind of do it on top of Mongo, and then it's easily portable. You're not going to be stuck on AWS for these implementations. Let's a quick example on how to send messages, receive messages just by posting something in a collection in Mongo. It's a very interesting topic, but just not enough time to kind of go into detail. The slides are going to be posted, and there's going to be a longer reference at the end. So schema and prompt config, really quick. They basically go through Fast API this time. So you go in the web browser, you go to Fast API, and then they're saved in MongoDB. But this is kind of the full pipeline for what happens when you upload a document. You upload a document through the Fast API. A message is posted to one of the workers to say, hey, run OCR, wait for OCR to complete. Another message is going to be posted to LiteLLM to do the multiple LLM queries for the document, because there could be multiple prompts. Pick the respective language model, and then eventually save the output in Mongo. So that's kind of the whole machinery end to end. And about LiteLLM, yeah, so I kind of started using LiteLLM maybe 2 weeks ago, and I really liked it because it does a really good job of getting the best functionality from all the language models. It's got a sync API and also an async API, and I need the async API, but it's very complete. So really a few lines of code. And that's pretty much it. And I think I'm almost at the end. LLM choices, pluses and minuses for each. So, for example, one of the things, like there's a Claude 3.7 now, right? Well, LiteLLM has not implemented that yet, so people are posting furiously to getting that to work. Really, Gemini 2.0 Flash, I can't say enough good things about it, because it's really pennies on the dollar compared to GPT-4o, and it's maybe 98% as good. And that's pretty much it. Yeah, I think, Yeah, that's the last slide is just an example of how I wanted to use cursor to kind of fix a problem in the project and how structuring the code in a certain way really helped. So the problem here was that my REST APIs did not begin with a version tag. They just kind of began from the root, like /orgs. No, I want /v0/org, so that next time I revision, I can basically support the older version. So I just went and asked it, hey, please update all the prompts. You can see here the question that I asked. And because the FAST API had everything in a single file, so that's kind of a trick here. I structured the code in such a way that it's easy for the AI editor and not easy for me as a programmer. And by putting all the APIs in a single file, then the AI editor doesn't need to search for the right file. It just finds it very quick. And I can also specify which files it needs to look at. And in this case, it worked great, but it skipped one that I had to fix by hand. And it skipped it because I was not good about putting it in the same file with all the other ones. Yeah, so I think that's pretty much what I wanted to show you. So, thank you.
Yeah, folks have questions, we can rotate around with the microphone.
Thank you for the talk. I'm kind of curious to hear what you put in your cursor rules. Cursor rules are really what's great for steering the LLM around.
So I've experimented with that. I had like more things and fewer things. Ultimately, I put fewer things in the cursor rules. I specify which frameworks I use. Like for example, I ask it, hey, please use Tailwind, don't use something else. And I try to specify the versions of the Next.js, for example. The things I've experimented with were, for example, giving like long instructions on how to use Fast API did not really make a difference. There was a great talk at AI Tinkerers just yesterday from a gentleman that explained how to use cursor rules in detail, because they keep developing these cursor rules and how to kind of layer them and how to order them. So you can do a lot with the cursor rules, but your mileage may vary. Maybe the simplest is the better. All right, thank you. Yeah.
Do you mind just showing it in action?
Well, I wish I could because I use Linux, but unfortunately, Linux doesn't work with presenting on the screen anymore, so I have to go on my Mac, so it's not really my development. This is not even my laptop, actually. So.
Okay.
But I'm happy to show you afterwards. I think I have it maybe on my laptop. Yeah, thank you.
Thank you so much.
Great, thanks so much. So I think we'll have like roughly like about a half an hour break, 45 minutes, half an hour break.